All right, are you ready? Whoops, let's get rid of this right here. Page 47. You're on conditional probability. It's number 3. This is a summary of the last 2 lessons, okay? These are kind of summary lessons on combinations and permutations. Okay, say combinations.
Combinations.
Easier because we use it for other things, right? A combination on your locker or just joining things together. But the word permutations is a statistics term. Say permutations.
Permutations.
And some of my students like to say permutation. Okay, permutation, right? I don't know, I say permutations. I'm not sure why. Okay, are you ready for the 3? There's a combination, and then there's 2 different permutations. One, there's no repetition, and one, there's repetition. A combination is simply a group, and we're drawing out several items from it. A permutation is a group that we're drawing out, and now the position matters. Like, let's say there's 10 runners, and we want to know how many options there are for first, second, and third place. We care about the position of each one that comes out, because that would be first, the next one would be second, the next one would be third. Does that make sense? We care about order. This one we don't care about order. If it's blue, green, red, we could have pulled out the blue first or second or third, as long as we got blue, green, red. Does that make sense? Okay. And then there's one with repetition. This whole idea that in the word yes, do any of the letters repeat? So it's just 3 factorial. Oh, by the way, say factorial.
Factorial.
And go back and review in your mind what factorial means. What does 3 factorial mean?
You're gonna multiply 3 times 2 times 1.
Good. Did you guys hear that? You're gonna factorial. 3 factorial means you're gonna multiply 3 times 2 times 1. Got it? You see it in your mind? Okay. So what's 4 factorial?
Multiply by 3 by 2 by 1.
Close. Where did you start?
4 people?
Start if it's 4 factorial, start at 4. And then go 3 times 2 times 3 times 2 times 1. You with me? So what's 5 factorial, Sophia?
5 times 4 times 3 times 2 times 1.
Good? And this is what happens. If you think about it, if I'm drawing out of 3 items, right? When I first draw out, there's 3 items there. But once I draw the first one out, how many are left? There's only 2 left. And after I draw one of those out, how many are left? You with me? You see why it's doing that? It's counting down because you're removing these, right? Here's the actual mathematical setup. N times n minus 1 times n minus 2, dot, 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 all the way down to 1. So if you were up here at 50, it would be 50 times 49 times 48, etc., all the way down to 1. Is that good? Do you see that? Okay. So then, can you summarize the 3 items? Combination, permutation, and 2 types of permutations. Can you summarize them? Who wants to try? This should be challenging, possibly. And you can read the board as you do it. Carrie, can you summarize the difference between the 3?
Combinations when you pick out of a larger amount and the order doesn't matter. The permutation without repetition would be like the order does matter and there's no repeating. And then permutation with repetition, the position does matter and there is repeating in it. It's
Yeah.
something like that. I don't know.
Yeah. And the craziness is, so that's nice. Thank you for that. That's very good. If you can do all that, did you guys hear that over there? It's a little bit quiet. I'm sorry for that. But thank you, because that's very good. The combination is drawing out of a larger set. The permutation is drawing out of a larger set, but we care about the position of the items we draw out, and there's no repetition, there's no repeating. Then there's a permutation where there is repeating, so we care about the order that they come out. but some of the items repeat. So for example, if there's 7 letters here, the total number of permutations would be this idea that you can just go to 7 factorial, right? And it'll tell you that number, 7 times 6 times 5 times 4 times 6. You can type it in your calculator. But now that we have 2 n's and 2 t's, this reduces this amount because you may pull out one of the n's or you may pull out the other n. Or you may pull out one of the t's or you may pull out the other t. So those start to reduce the number of overall options that produce. And with that, I might just stop at this. And that's our summary. Do you have your calculator? Who's got their calculator handy? Type in this one for fun. Type in 0 factorial. Type in 0. What do you get? You get 1. Interesting, huh? I want you to think about that. That's your brain teaser. Well, you could just Google it. Just Google, why is that? But that's your brain teaser for the moment, okay? Okay, good. This one's going to be short.